Okay, we're going to start with the warm-up. So the difference of a positive number and a negative number is always positive. We need to find a counterexample to show that the conjecture is false. So what we're going to do is let's just take a positive number and a negative number. Let's take -6 and 4, and then let's find their difference. So if we did -6 minus 4, this is going to give us -10, and this proves that the conjecture is false because it's not a positive number. It was -10, okay? So this is counter example. Okay, and then number 7, if a triangle measures 180 degrees, each angle is 60 degrees. You could use as a counterexample a right triangle, because we know right triangles have an angle that is 90 degrees. Okay, so this would work as a counterexample. All right, today we are covering chapter 2, section 3. We're using the postulates and diagrams. So again, this is chapter 2, section 3. So there are 7 postulates in this lesson that you guys need to remember, okay? We all know what they are. It's just a matter of recognizing what they're called, okay? So the 2-point postulate is through any 2 points, there's exactly one line. So if you start with 2 points, you can draw a line through those 2 points. The line point postulate is a line contains at least 2 points. So if we started with a line, you're able to say that there are at least 2 points on that line. The line intersection postulate states if there are 2 lines and they intersect, their intersection is exactly at 1 point. So if we have 2 lines that intersect each other, we can say that that intersection is exactly 1 point. The 3-point postulate, through any 3 non-collinear points, there's exactly 1 plane. So if we had 3 points that are not collinear, okay, they all don't fall in the same line, we can assume that there is a plane, exactly 1, that contains all 3 of those points. There is a plane with 2 points and then connects them with a line, and that's the 2-point postulate. All right, so the plane-point postulate, a plane contains at least 3 non-collinear points. So now we're going to start with a plane, and we're going to say that there are at least 3 non-collinear points inside this plane. Okay? The plane-line postulate, if 2 points are in a plane, then the line that contains them is in that plane. So 2 points that are in a plane, we're going to start with 2 points inside of a plane. And if we were to draw a line through those 2 points in that plane, the line that contains the 2 points would also be in the plane. Okay? The plane intersection postulate is if 2 planes intersect, then their intersection is a line. So I'm going to draw this the best that I can. So this intersection is a line. The intersection of 2 planes is a line. So a plane contains at least 3 non-collinear points. So let's go. We want to find out which one starts. All right. A line is perpendicular to a plane if and only if the line intersects the plane in a point that is perpendicular to every line in the plane that intersects at that point. So let's go ahead and write that this is a biconditional statement. Okay, we know it's a biconditional because it says if and only if, right? And what this is basically saying is if this line T that we see over here is perpendicular to the entire plane, that would be the plane that we see below, plane A, okay? So line T is perpendicular to plane A. That's saying that any line in plane A, so Q and P, line T must then be perpendicular to, I'm sorry, I'm writing this really poorly. So line T must be perpendicular to line P, and line T must be perpendicular to line Q. And the reason we know that is because line Q and P are perpendicular or lie inside the plane A. And we know that line T intersects plane A at a 90-degree angle. So it is perpendicular to the whole plane. So any line in A would be perpendicular to line T. Back. All right, example 1. So state the postulate illustrated by the diagram. This one says if there are two lines that intersect, then their intersection is exactly 1 point. This is the line intersection postulate. So let's put line intersection postulate. And then B says if two planes intersect, then there's a line in between them. That is their intersection. That is the plane intersection postulate. Look at it. Use a diagram to write examples of the plane-point postulate and the plane-line postulate. So the plane-point postulate, let's do that one first. I'm going to write that one in yellow. So the plane-point postulate states that if there is a plane, well, actually we can go back. So let's pick a plane, let's pick plane P. Plane P contains A, B, and C. Points A, B, and C, which are non-collinear. Okay, so we started with a plane P and we picked 3 points that are non-collinear and we labeled them, so A, B, and C. All right, and then the next one, we would like to do the plane-line postulate. That's saying that let's also use plane P. Plane P contains points A and B. And also the line connecting A and B. Okay, because the plane-line postulate says that as long as 2 points lie in the plane, the line that connects them is also in that plane. We could label it or line N. Okay, postulates. Example 3, which of the following statements cannot be assumed from the diagram? Okay, the key word here is cannot. So I'm going to highlight the ones that are not assumed by the diagram. A, B, and F. A is over here, B is over here, and F is over here. They are collinear, so we cannot highlight that one because it can be assumed. All right, next one, E, B, and D are collinear. Let's find E, B, and D. There is no line connecting all 3 of them, so therefore we cannot say that they are collinear. We're going to highlight this one because it works. A, the line AB is perpendicular to the plane S. So let's find the line AB, which is this one. Is it perpendicular to the plane S? That's the red plane. Yes. The reason I know that is because of this 90-degree angle sign that lands on the plane S in the red, okay? So we can assume that one, so we're not going to highlight it. Remember, we're only highlighting the ones that cannot be assumed, okay? And next, we've got the line CD intersects the plane T. So CD is right here, that's this line. Does it intersect the plane T? No, the reason we cannot assume that is because there's no 90-degree angle here showing that it intersects at a 90-degree angle. So this one cannot be assumed, so we want to highlight this one. And then lastly, AF intersects BC at point B. So let's find those two lines. So we've got AF, that's this line right here, intersects BC, that's this line right here, at point B. Absolutely, that one works, so we are not going to highlight it, okay? All right, name a pair of supplementary angles and a pair of vertical angles in the diagram. So remember, supplementary, we should always think of 180 degrees. Supplementary SS, straight, it should form a straight line. So two angles that form a straight line, there's a few of them, but we could label PWV, that's this one right here. And then we could have also labeled VWQ. Okay? And then pair of vertical angles. So vertical angles we could have said were PWT. And then also we could have said VWQ. So this first one were the supplementary. And the second one were vertical. Okay? The reason we know that is the vertical ones are when two lines intersect, they are opposite of each other, or they don't share any of the same sides. And then, but they share a vertex. And then the supplementary, remember, together, they were gonna form 180 degrees or a straight line. So that's why we picked PWV and VWQ. Back. Okay, so it wants us to state the postulate illustrated by the diagram. For this example, this would be 2 points that form a line. So let's go ahead and write that in there. That was the 2-point postulate. Okay. Our practice to state the postulate illustrated by the diagram. This is the Plane-Point Postulate. Because this is stating if there exists a plane, then there are 3 non-collinear points inside of that plane, at least 3 non-collinear points. All right, next one. Practice 3, use the diagram to determine whether you can assume the statements. So planes W and X, that's this plane and this plane, intersect at KL, that's this line. Oops, you can't see it when I draw in black. That's this line right here. That is absolutely true. So we can assume that one. Points K, L, and M. Let me erase. And let's find points K, L, and M are, K, L, M, and N are coplanar. That one's correct too, okay? They all lie on plane X. The points Q, J, and M, Q, J, and M are collinear. There is no line that goes through those 3, so we cannot assume that one. Was on this slide, and it was points Q, J, and M are collinear. Practice 4, use the diagram to determine whether you can assume the statements. So we're doing the same thing, same diagram. All right, so JK, that's this line right here, must lie on the plane X. That one's correct. NKL, this one's a little tricky. NKL KL as an angle, okay? And JKM are vertical angles. Well, we can see that this line and this line intersect at K, and this angle is opposite this angle, so this one is correct. Okay? And then NKJ that's this angle right here, and JKM are supplementary angles. That one is also correct, because if you added these together, they would give you 180 because they form a line, which is the line NM. Okay, so this one's correct as well. So the only one we could not assume. All right, here's your homework. Good luck. Let me know if you guys have any questions.